All right, so that's kind of where the idea started for qBraid is essentially we were, Kanav, our founder, was essentially like, this can't be the way the future of quantum should be. And do you guys see my screen? Just want to make sure you guys see
Yes.
slides. Okay, perfect. So, he mentioned like, this can't be the way quantum should be. Like, we're going to be doing really cool stuff. And why are we being stuck in this classical land and doing classical stuff? So what happened is, qBraid has been trying to automate a lot of these classical things and making sure that it's all smoothly packaged for the quickest experience in getting into quantum and developing on quantum. And we offer essentially three products, which is like the learning platform, which I'll show very quickly today, a lab platform, which is like the development platform. If you've used IBM Q, it's slightly similar, but we'll show kind of the features that make it a lot easier for someone who's done quantum computing to access different quantum devices. And then finally our SDK. So starting off, learn. I think always the great question is like, where do you get started in quantum? Do you start with the math? Do you start with physics? Do you start with, I don't know, the computer science? Do you start with quantum mechanics? It's a very nebulous field, and we make it very easy for anyone to learn. We have like a three-prong approach that that starts you with complex vectors and then like moves you all the way up into Deutsch's algorithm. And it's been, endorsed by the White House Q12 initiative. And we really think that what's great is we have like if you've used Medium to say, today I was looking up like how to use Webpack configurations for React. And you can't copy the code or you can't run it yourself. So we've made these cells that are like runnable. So you can build a blog yourself and then you can just essentially run it and other people can edit it as well freely. So that's just some of the features that we have. And we have a course, as mentioned before. It's freely available. Anyone can take it. There might be some bugs, but as the week progresses, I will be fixing all of them. And we also have quizzes. And a little bit about this, we have actually been partnering with UCI and have one class where they have used their platform and they had about 60 students. The course was 10 weeks. And if you're a university, you don't want to go through the first 4 weeks like helping students get started and like setting up. There's none of like the setup that's necessary, like Qiskit, all of these like environments for you that's necessary for quantum code programming are essentially ready to go in qBraid. So no installing, none of the dependency issues that you may usually face. And that's what qBraid Lab is all about. So as I've mentioned, we have this entire crazy classical stack that people have to deal with on a regular basis. And we've taken that and just abstracted it and cleaned it all up so you can just focus on the quantum stack and just get coding immediately. Yes, my computer gets very slow after a while. Okay, so we have, you have the ability to do cutting edge research, which I'll be talking about a little bit more. And then what's great is we have this whole environment that's essentially catered for anyone who's getting into quantum or doing heavy research, where they can upload to GitHub, use the Jupyter Lab environment that they're familiar with, and then also have Qiskit, Pascal, Amazon Broadcast Circ, and so much more just ready out of the box without any installation. What's even greater is how many people have used like AWS Broadcast or like, have used like Amazon cloud services or AWS web services? I don't know, just so if you haven't, you may find it daunting. If you have, you know how tedious it can be. And for quantum computers, it's definitely a arduous process because you have to make these things called like a storage service called S3. You have to make a role, which is an IAM role, and you also have to sign up and create an account. We just have one command line argument, and you're able to connect to all of these quantum computers without ever creating all of these like cloud service resources. And we intend to do this with IBM as well and other quantum cloud providers. And essentially, now you have all your quantum computers at your fingertips without any installation or any cloud service or cloud management. We also have GitHub Actions, or sorry, not GitHub Actions, but GitHub functionality, so you can clone repositories. And we also have code snippets, interactive widgets. Essentially, this is built for you to access trapped ions, neutral atoms, superconducting qubits, photonic qubits, or even simulators, all of them readily available for you without any installation. Just a quick case study we've done with the disruption lab at UIUC. They have worked on a quantum financial optimization using Qiskit, and we have one of the first transpilers between AWS Brocket, which is a quantum computing language, and Qiskit, which is another one by IBM. IBM's arguably has like a lot of cool financial optimization or like machine learning packages that would be great to run on all the wonderful devices that Amazon Brocket offers. But you know, there hasn't been a way to transpile your circuit, so you'd have to rewrite it again. And so they were our beta users where they were able to use our SDK which our CTO made, to essentially build whatever they wanted to build. And in this case, they did a financial optimization and were able to run it on AWS Brocket devices. And speaking of which, so the qBraid SDK has integration for Cirq, PyQuil, Qiskit, Brocket, and Penny Lane. So any of these languages you may be familiar with, you can translate them. So the circuit will transpile between Cirq to Brocket or PyQuil to Qiskit. All of this, I can send in documentation links later, as well as a demo. It's available now on qBraid. And essentially, this makes it very, very convenient for you to maybe use a Penny Lane variational quantum circuit template and then transpile it to PyQuil and then run it on a PyQuil device, or maybe transpile it to Qiskit and whatnot. So essentially, we try to be agnostic. We do not compete. We empower the ecosystem and are trying to essentially make it as easy as possible to access as many quantum computers as possible. And Vince was there at QC Hack. We had a really cool solution that was provided for our Grover search problem, where this isn't topology of the quantum computers. This is just essentially the results of Grover search for a Hamiltonian cycle, where a team was able to use 5 devices and find various different cycles of Hamiltonian cycles on a provided graph. Yes, finally, we're definitely trying to build this community, and we have like blogs, news, events, and papers that people can sign up for or read, which I'll also get into in a bit. And we have 4,500 universities and enterprise users, and we'd love to have more. If you guys would love, I'll drop my email. We can definitely just kind of talk about these things. And that's about it for my presentation. I know Kevin says 7 to 10 slides, but I hope that was within the 7 to 10 slide time limit.
No, that's fine. Yeah, we're interested in kind of like that culture. A lot of us, aren't doing what you're doing every single day. So could you take us into that as far as your company and other companies you work with?
Yeah. Culture. Yes, I think the culture is very collaborative. I think quantum is going to take a lot of work. It's non-trivial. People from all walks of life are more than welcome, because the most interesting kind of phenomena happen when 2 tangential ideas come together. And so I think that's part of a large community. That's part of like QOSF, QHack, QC Hack, as well as Quantum QWorld, and all of these organizations, as well as qBraid, have been fostering. And then I think there's also a very strong research community as well that's very hardware focused as well as like algorithm focused. I don't know exactly like what sentiment you're looking for about the community, but that's like my take at least.
Yeah, and kind of tying into, obviously you have competitors. Could you go over some of your benefits over other people in the industry that kind of do similar things?
Yeah, absolutely. I think one of the benefits that we have is I guess like maybe showing a demo might work here, if you don't mind.
Oh, go ahead.
Yeah, so I think one of the cool things is, we have, say, let's just do the QKD demo, and I'll kind of click on that, let that load. What we're really trying to focus on here is to bring a really personalized experience in quantum, which, involves being agnostic in terms of device. And we really do focus on that. And we also have, say our competitors may perhaps only have like one kind of device, but we have a slew of devices, including trapped ions, quantum annealers, superconducting qubits. Like these are just some of the things we offer. And I think we are really focused on developing like the learn, build, and deploy. So we have this learning platform, which I'll also load as well. So this is our Qubes visual course, which is our course that we provide freely for anyone to use. And these are just some of the things that I think that we do very well, is that we understand, given the fact that the entire team has gone through the quantum software development and like the learnings of trying to get into quantum better than from top to bottom, essentially. Like I think we do that, very, very well. I think arguably we do have a team that's like been through some of the pain points that we are working on. And I think that's our biggest sell. And so this is the course that you can maybe take today. We have videos by Andrea Coladangelo. We have questions as well. And then you can also just run these cells and essentially get code. And you can even write your own code and essentially, well, get your results here, which you can, using qBraid Lab, I think this is one of our biggest sells as well. You can post your own blogs and then show this to others about your understanding, your learning. So if you want to do quantum key distribution, you can write your own code and your friends can just try it out and be like, hey, this is really cool how you've like made sure that, you've gone through your understanding, and people can fiddle around with your code and write into it and then copy it themselves or try it out on their own. And I think this entire like positive feedback loop is what we're really trying to focus on, and I think is one of our biggest sells.